So welcome back to one more presentation on our Internet of Things fundamentals. A quick recall of what we have seen so far in our fundamental discussions. Uh, since we are about to start a new topic today, a little recall of what we did in the previous presentations, whatever we have taken so far. So that would definitely help you in understanding, the connectivity between the topic to topic. So we started from the fundamentals of IoT, where we have seen the different frameworks, then the different communication technologies that are used in your IoT. Then after that, after having seen the fundamentals, we have moved on to the second aspect there, that is the design principle of web connectivity, or the design principle of internet connectivity, the different the protocols that are used in your internet. We have seen there, right? After having seen that, we moved on to the next layer, which is the application layer. We went to the application layer, and in the application layer also, basically we started discussing about how exactly the data management takes place. The data management. So in the data management, we have seen how the data is generated, acquired, organized, validated, and analyzed. The data analytics also we have seen. After that, where exactly the data analysis takes place, in that connection we have discussed about the cloud computing paradigm also, to a basic extent, wherein we have seen the different services, the infrastructure, the data, then the platform, the software as the services we have seen, right? And the different service providers also, right? As long as these services are concerned, that also we have seen in a nutshell. Now, after having seen all those things, now we are again coming back to the physical layer, because earlier we started from somewhere here, we went up to the application layer, right? So in a nutshell, we have seen what are the different things that are involved in all these things. Now we will be coming back again to this layer with the detailed discussion on whatsoever we are supposed to do here in the physical layer. Okay, so whenever I speak about the physical layer, it is merely confined to the collection of the data from the different devices. Ultimately, when I speak about the application of the Internet of Things, right, we by this time we should be in a position to be very clear what exactly is our intention, what exactly is our goal. You have something physical parameter given by some changes which are taking place physically or intentionally as per your industrial process operation or something like that. Then those changes are to be sensed, then the changes which are sensed are to be enriched, gathered, then they must be put it in the proper format. If at all you want to have the analysis of those changes, or what we in general call them as data, in the application layer, maybe you make use of your own the data analysis entity, or you can make use of the cloud services, which are very common nowadays. So after having put your data there, so you should get something out of it. You should be able to take a certain kind of decision based on what has happened there. So that decision is believed to be helping you in your overall the enhancement of the business, or whatever the service you want to provide, either to an entity or a community, whatever it is. So finally, if at all you want to have the accomplishment of the complete task that you have started with, then you need all these services. So now, after having seen what comes where, till you start from your physical layer till you go to the application layer, or you may come from application layer to physical layer also. Now we will try to see how exactly these things are going to be implemented. We have already gone through the understanding phase. Now we have come to the second phase where the different things are to be implemented. So whenever you want to have the implementation of a particular application using IoT, right? So basically we start with the measurement of the different quantities, right? Then gathering, enrichment and the other things will come later, right? So as long as the measurement is concerned, we would always start with what we call it as the sensors and their network. So this network is not related to what network we have seen so far. It is not related to the network in the internet domain. So it is the network of the sensors themselves, right? So in what way you should be able to capture the data in the most appropriate way that you can, so that that data becomes a reliable data for you to have the further analysis and all, right? So in this particular module, basically we will discuss about the different sensor technologies, right? Analog sensors or the digital sensors, some of the examples of these sensors which we generally come across in our IoT paradigm or the IoT environment. Then how we have the sensing of the things. So I have already given you the meaning of what we call it as a thing, right? Then could it be a barcode, could it be a QR code? Nowadays these are very popular as long as sensing something is concerned. All of you must be aware of that. Could it be a motion sensor, a pressure sensor, right? Maybe the environmental monitoring sensors. So what do we mean by participatory sensing? This is a new word probably, right? So participatory sensing, what exactly the participatory sensing is and how it is different from your conventional sensing. Then we will be looking something about the industrial IoT, right? How your IoT can be used from the point of view of the sensors in the industrial applications. Then what exactly are the actuators, right? So after having seen what exactly are the actuators, then we will be having more or the detailed discussion on what we have earlier taken as RFID technologies, radio frequency identification technologies, and also WSN, wireless sensor network. So these two in detail we will be discussing, because the RFID and this WSN, they become a part of our measurement techniques or the data gathering techniques, right, in our IoT scenario. So therefore these are the different things that we are going to discuss or understand in details, the different sensor technologies for sensing the real world parameters. Could it be using the analog sensors or digital sensors, with the specific examples confined to the IoT and machine to machine communication, right? So we will not be able to discuss all the so many types of the sensors which are available today in the market, which are very popular, which are very much confined to our customized requirements in IoT or the machine to machine communication, right? And also we will be discussing about the principle of the participatory sensing, then industrial IoT, to some extent the automotive IoT also, right? Then what exactly we mean by the actuators, then how you will be using the principles of your RFIDs and wireless sensor networks. So these are the different things that we are going to discuss in this particular topic. Compared to the previous topics, this topic must be relatively very simple, because these are related to the physical things, which being the students of electrical and electronics engineering, so you should be able to quickly understand many of the aspects here, right? Maybe when we use these things, we will really come to know what are the physical constraints, what are the real time bottlenecks you have in the operation of these things and all. But as long as understanding is concerned, there should not be any problem, because some of these sensors you must have already been familiar with. Okay, so with this a brief background of what we are going to study, let us now quickly keep looking at the different aspects which we are supposed to study in this particular course. Okay, so as you can see here, the sensor technology, when I speak about the sensor technology, again I repeat, the sensors play a very important role in the overall successful implementation of any IoT project, provided you have something to be measured in real time, right, for your analysis. So a technology for designing the sensors and associated electronic readers, circuits and devices. So this is what we call it as sensor technology. Please keep in mind that sensor is different and the sensor technology is different, right? Sensor happens to be a single entity, whereas the sensor technology involves the multiple parameters which design a system in order to make sure that your measurement is complete and perfect, right? Maybe with the help of electronic readers, electronic circuits or the electronic devices. Now if you look at this diagram quickly here, so probably you should be able to look at the different the sensors, right? A quick look at all these things. You have the thermistors, you have the IR sensors, right? You have ultrasonic sensor, you have gyroscope sensor, accelerometer sensor, you have rain sensor, right? Moisture sensor, photo sensors, water flow sensors, right? Heartbeat sensors, alcohol sensor. Like that, you have so many sensors in our day-to-day life which we come across. We have the color sensors, right? So we have the gas sensors, smoke sensors, temperature sensors. Probably this kind of sensor you must have used in your practicals, right? IR sensors, LDR sensor and so many, right? So this is one example which I just wanted to take as a part of our discussion. So many of these sensors we should be in a position to use them in one or the other way in our applications. Probably when you come to your sensors and control system lab in your next semester, in the 6th semester, so you have certain experiments to be conducted on this sensors. Maybe we will try to expand the use of this from the point of view of the IoT. Even we will start or we will proceed to store the information that is measured by these sensors into the cloud also, so that we should be able to understand how exactly in real time all these data communication from your physical layer till the application layer or in the internet layer takes place, right? So that should give you a fairly good idea about what exactly an IoT is before you start implementing simple and small projects on these things. Okay, so now after having seen the definition of what exactly is the sensor technology, the technology for which is used for designing the sensors and associated electronic readers, circuits and devices, now we shall move on to the different parameters which we sense, which I have already made a mention in our previous slide itself. It senses change in the physical parameter. Now you should be able to differentiate between what a sensor is and what a transducer. What is the difference between a sensor and transducer? You should be in a position to understand, because these things are very elementary and fundamental knowledge that you are supposed to possess before you make use of the sensors for any applications, right? Basically, when I say sensor, it senses a change, right? Could it be in its surrounding, right? Around an object, right? Whatever it is, you have since I have already mentioned some of the sensors in my previous slide, so there should not be any necessity according to me to explain what could be these changes, okay? And the output is given in the same format. Please try to understand. If at all you have got a sensor which is sensing a leakage of gas or something like that, the output will be given in a typical format, need not necessarily be it is an electrical signal. So this is a very important point to be noted. Whereas the transducers are essentially the sensors only, but they are in a position, or they are capable of giving the output in the electrical signal formats. Could it be voltage or could it be current, whatever it is, depending upon the requirement. So definitely transducers are well suited as long as our applications are concerned, because when you have the output in the form of electrical signals, we always take the advantage or the privilege of getting those signals as per our requirement, right? So all the transducers are sensors only, but not necessary that all the sensors should be transducers. This is one point to be noted before you go into the physical parameters which are being sensed in your sensors, right? Senses a change in the physical parameter. What are those physical parameters? I have already made a mention earlier also. You can have a quick look at these things. It could be temperature, pressure, could it be light intensity, metal proximity to an object, smoke in proximity, acceleration, orientation, location, vibration, smell of the organic vapors or gases, something like that. So these are only a few of them, right? Please try to keep at the back of your mind. You can have anything nowadays to be sensed, almost everything, right? So these are some of the important things which we may deem that they come in our domain of using the Internet of Things. Okay, so these are some of the important physical parameters that could be sensed using the sensors. Then I have already told you about what exactly is the meaning of transducer as a sensor. Converts physical energy like heat, sound, strain, pressure, vibration, motion, etc., which otherwise could have been only at the sensor level, into the electrical energy. Whenever the electrical energy comes into picture, you call it as transducer. Electrical energy, in the sense, it is either in the form of voltage or current. The signals are to be are necessarily be in the form of either the voltage levels or the current level, right? Voices and change in the sounds used to record voice or music. So these are all in the form of the electrical parameters only, right? So the transducer as a sensor, whenever I speak about the transducer, I will bring the output in the form of electrical signals, right? So this is another point to be noted. What are the electronic circuits for the sensors? When I have only sensor, is it sufficient for me to read the data completely or capture the data completely, or do you need any associated circuitry to make sure that the data is read properly? So all these questions arise, right? The electronic circuit for the sensor connecting to the input at a sensor. Circuit input receives the output of the sensor or transducer. The circuit output variation is according to the variation in the physical condition. So when I have something here, this is my electronic circuit. So you have something here, you have something here. Now this will be my output, this will be my input. Togetherly, this electronic circuit having a sensor, a part of it, results in the complete sensing circuit, right? So independently you can call a sensor always, but sensors with the proper features of the electronic circuits will be able to deliver the task of measuring the changes in the input parameters with a reliable and accurate manner. Okay, then after this we have something called as the sensor circuit. When we say that, these are all the fundamental the definitions which you need to understand after having seen what is the sensor, what is the difference between a sensor and transducer. So what do you mean by electronic circuits used in the sensor technology? Then the sensor circuit receives the energy in the form of variations in the current, voltages, their phase angles or frequencies. Not necessary that they should be variations in only in the current and voltage. Could it be in the form of the phase angles or frequencies also? As you come across more and more applications later in our electrical engineering scenario, right, you will come to know about, so in what way the phase angles and frequencies changes are also made responsible to measure some of the changes in the electrical parameter, right. Sensor measures the variation in the parameters with respect to a reference or normal condition and provide the value of sensed parameter after appropriate calculations. Please look at this word calculation. Whenever I talk about the calculation, mere sensor does not support it, but you may have to have the sensor circuit. So these circuits are intended for whatever the post measurement parameters are there, which you need to put it into your higher layers. We have used the terms called as the gather and enriching the data. So for which you need some of the electronic circuits to work at the background to convert the values with respect to the which are measured with respect to a reference or normal condition, and to provide the value of the sensed parameter with appropriate calculations. Okay, this is about the sensor circuit. Now, whenever I speak about the sensor circuit or the electronic circuits which are involved with your sensors, so directly what comes to my mind is the microcontroller, right? All of you are very much familiar with the microcontrollers, and these microcontrollers along with the other important interfaces, you can see here the serial port interface SPI and the sub-circuits. So these sub-circuits may be related to the auxiliary things which are required here. So now the data direction is this way. You have got the sensors, right? Maybe a capacitance type of sensors, which we will study later. I am not going into these details now. So the parameters in the vicinity of this sensor, could it be the change in the humidity, could it be change in the the atmospheric conditions in terms of getting heated up, getting cooled down, anything, right? So they are measured with the help of the sensors and through proper serial peripheral interface, right? So the values will be provided to your microcontroller. Now from the microcontroller, whatever the calculations that I have mentioned here, the calculations, right, those calculations do take place here, and the values which are basically a raw data here, right, they are properly analyzed and organized, gathered, enriched, and they are ready to be put into the next layer. These are all very, very common and primitive things that you have already come across long back, okay, in your microcontroller studies, right? So the microcontroller or the electronic circuit port connected to interface and sub-circuits and receiving the input from a sensor, maybe if it is a capacitive sensor whose capacitance value is varying with the relative humidity of the air, and the circuit sensing the variation of the relative humidity. Anyway, I will take up this kind of examples in my subsequent discussions, right? So that is what we mean by the electronic circuits associated with the sensors. Without the proper or appropriate electronic circuit, it is not possible for us to have the proper measurement of the data before it is put into our higher layers. Okay, then the next one maybe as the continuation of what we seen in our previous slide, what we call it as a smart sensor, right? The basic definition of the smart sensor I have already given you long back. The sensor, along with the measurement, it has got the communication ability also. The measurement and communication ability. So that is the reason why I have shown you in this diagram a computer, right? Those sensors could be conventional sensors here, but when I have got some kiosk there, some handheld device, computer, then it indicates that these sensors must be smart sensors, right? So measurement plus communication ability, if it is there for a sensor, then we call it as a smart sensor, right? So a sensor with a built-in integrated circuit, microcontroller and sensor, to directly give the output as the physical parameter on giving the input supply voltage and other signals and commands. It is the other way of defining the smart sensor. Along with the sensor, there are something else, and what this something else I refer to, what exactly they do, that's what we have the meaning as the ability to have the communication. You take the data, you measure the raw data, transform that data into whatever the usable format that you wish to keep them, so that they are easily transformed to the subsequent layers for the further analysis or the interpretation. So this is what we mean by the smart sensor. Then after having seen the smart sensors, let us look into a couple of examples here. Please look at this example. You may have the different examples as well with you. A smart sensor for temperature giving an output in terms of hex digit as 10 UART serial bits according to the temperature in degree centigrade. That means, see here, this is one value giving it for 100 degree centigrade, and this is another value which is giving you the value for 36 degree centigrade after taking the calibration coefficients also into account. So you know what is the meaning of the calibration, right? In order to make sure that the data is read without much deviations with a maximum possible resolution, it is always required to be calibrated. In your measurements, you must have studied about all these things, right? Even in the smart sensors also, all these provisions are already incorporated. That is the reason why they are called as the smart sensors. And here in this particular example, you are giving or you are getting the temperature in degree Celsius between two values. One is say 36 degree and another for 100 degree. So which are being shown by two different digital numbers, right? And accordingly you can have the values in between also. Maybe this is a sensor which is capable of measuring the temperature between 36 degree to 100 degree centigrade. You can have anything as your requirement, provided that particular configuration of the sensor permits that particular measurement, right? So you have one more example for the relative humidity here, right? In terms of the hex digits at as 10 UART, universal asynchronous receiver and transmitter serial bits, after computations as per the temperature of the measurement. Say, let us say that this is the value which is given for a relative humidity of 60%, and again if you measure the values with all the calibration parameters being taken care of properly, it is possible for you to express maybe the different percentage of maybe 30%, 40%, 80%, 90% of the relative humidity at the different numbers here. So this is one example of what we mean by a smart sensors. A sensor with measuring as well as the communicating ability, and within the embedded structure, all the manipulations which are supposed to take place for the measured raw data, they are going to take place, and they will be in a position to be put for the further layers for the analysis and interpretation. So now we come across one more type of the sensors, that is the sensors which sense the change of state. Sensors which sense the change of state. So here when we speak about the change of state, probably all of you must be knowing about I mean you get the example of your touch sensor in your mobile phones, right? So either you touch it or not. Sometimes even before you touch your the screen, you get that feeling that it is already sensed. That is because of the sensitivity, the higher sensitivity that you have in your sensors. So, okay, so sensing the circuit with zeros or ones as per one of the two states, the change of state, for example, light to darkness, right? You must have seen the light meters which are used whenever the light value is less than certain lumen, game and all, in your cricket matches and all, you must have seen that, right? So they have some threshold there, right? If the light value is less than certain lumens, the condition is not favorable for continue to play. Otherwise you can continue. So only two values. If it is below this, no play. If it is above this, you can play. This is a kind of sensor, right, based on the change of state, right? Finger touch, this example I have already given you just now, right? Proximity or far, whether it is, see, you have got some device here, right? So now maybe suppose if it is a door, okay, people start entering inside. So whenever a person passes through it, right, depending upon his proximity to the sensors which are deployed here, you will get the actuation there, right? Either it is proximal or it is far. So completion of a revolution of a wheel, right? You have got a wheel, right? So now you, once you deploy it somewhere here, the sensor, once it takes 360-degree rotation, then I mean this is used in your tachometers and all, right? Probably you have come across how the tachometers, I mean the photo tachometers work, right? So I need not give any example on this. Tire pressure below threshold value or the above threshold value, you must have taken your vehicles to put the air to the tires, right? So they set, I mean 35 pounds or something like that in your cars and all. Once it reaches 35, automatically it gets cut off, right? So if the setting is 30, once it reaches 30, automatically it gets cut off. So these are some of the examples which our sensors are used to sense the change of state. Okay, so then we have some examples here, right? So which are meant for multi-parameters, I mean the sensors which are deployed for measuring the multiple parameters. Let us not much worry about the brands here, right? But only thing is that we should take the example and how your integrated multi-parameter sensors or boards work, right? So you have something called as Bosch XDK 110 development kit, which includes devices. So 8 numbers of your MEMS devices. You know about this micro electromechanical systems, which is a very popular field nowadays. Maybe you have got one elective in your 7th semester, if I remember right. So if we are really interested, you can opt this particular elective, right? Basically it is a micro electromechanical system, and it relates to the micro materials, or you have something called as mechatronics. Mechatronics means mechanical plus electronics. I mean the electronics that is used in your mechanical system, mechanical plus electronics, right? Micro mechatronics and micro systems, which constitutes this overall technology, right? Suppose if there is any problem inside the body, right, where the doctors cannot interrogate it, right? They cannot inspect it. Then you can make use of these kind of devices, MEMS devices, and you can put it inside the body, and they should be in a position to find out what or diagnose what exactly is the problem there inside the body. Maybe the micro electromechanical systems are very useful in these cases in your biomedical fields and all. Okay, so this Bosch XDK110, it includes 8 numbers of micro electromechanical system devices, and you have got something called as the accelerometer, magnetometer, gyroscope coupled with relative humidity, pressure, temperature, acoustic and digital light sensors, right? So this is one example where one device which is used to measure the multiple system parameters, and whenever you have the multiple system parameter, you should select these parameters in such a way that they should be related or they should be correlated to each other, so that in a particular scenario, most of these parameters should be in a position to be measured, right? So you measure distance somewhere, you measure temperature somewhere, you measure height somewhere. These kind of things you cannot have, right? So the things which are being measured, they should be correlated to each other. Maybe so the accelerometer, magnetometer, I will come across all these examples later. Gyroscope, relative humidity, pressure, temperature, acoustic, digital light sensors. These are all confined to a particular applications. Maybe they are different physical parameters, but in totality they may be required to measure certain or to come across a concrete evidence of some physical changes or some experiment which is being carried out, right? So this is about one example which I wanted to give you on the multiple or multi parameters which are integrated in a single sensor, right? Then after having seen all these sensors, right, let us take a small pause here, because continuously speaking from one side would always make you to feel bored or monotonous, right? Let us have a small pause here. Again, quick recall, we are discussing about again the physical layer parameters now here, and for measuring the various parameters at the physical layer, we have something called as the input. Then these inputs are now being measured from what we call it as sensor, right? We have already seen what exactly is a sensor. Then we have made the differentiation between the sensor and the transducer, right? Then after that we have seen what exactly is the sensor circuit, what exactly is the electronic circuit that is involved in the sensor, right? How you make use of the microcontrollers for the different parameters which are to be processed after they are being measured at the sensor level, right? So how we will have the different ports, the serial peripheral interfaces there, that also we have seen. Then afterwards we have seen what are the different parameters that are being measured using the different sensors, right? So then we have seen some of the examples of these sensor circuits, maybe with the sensors having integrated parameters to be measured in the sensors with the help of one example. Okay, so now with this small pause, now let us move on to the next aspect, which is the analog sensor. So you have two types of sensors, the analog sensors and digital sensors. Needless to mention, how do you differentiate between an analog quantity and digital quantity, and accordingly you have the classifications as the analog sensors and digital sensors. First, let us quickly look into some of the aspects related to the analog sensors. Uses a sensor and associated analog electronic circuits. Analog sensors generate analog outputs as per the physical environment? Could it be temperature? Please try to differentiate between what we mean by analog outputs and what we mean by digital outputs. Temperature, pressure, force, flux. Let me come to this later. What exactly is the flux? Vapors, magnetic field or proximity distances, stress, strain, right? So pressure, many things, what not, most of the things, humidity, rain sensors, right? All these things are coming under the analog sensors. Resistance of the sensing component may show measurable changes with the surrounding pressure or strain or magnetic field or humidity. Now, what I mean by this is, whenever some changes takes place, right? So delta. So now, how do you identify this? There are different means. One mean is to have change in the resistance which changes from R to plus or minus delta R. Resistance can either increase or the resistance can decrease, R to delta R. So this is one kind of thing which can take place in your analog sensor. Resistance of the sensing component may show measurable changes with surrounding pressure or strain or magnetic field or humidity getting changed. This is one thing. Then you have the same slide here which is coming once again. You have a flex sensor, right? One is whenever the pressure changes, whenever the force changes, or whenever the humidity changes, right? Whenever the strain changes, you will have the change in the form of R plus or minus delta R, where delta R is the change, right? So now with the same thing, let us, when you proceed further, we have something called as the flex sensor. As the diagram is showing you here, you can see it from this diagram. Okay, so what exactly you observe in the flex sensor, right? You can come across something that is a flex sensor. As you can see, example 2.2 inch or 4.5 inch length. There are different specifications as long as the flex sensor is concerned. Resistance across the sensor strip increases on flexing. Whenever you put the pressure on both the ends of this flex, right? So resistance across the strip increases. Here it is R plus delta R only in this particular case, specifically in this particular case, right? Resistance changes or changed path and deflection of the sensing resistor. So now when the resistance changes here, right? So what you do, how do you relate the change in the resistance? Say, let us say I have got a Wheaton's bridge here. All of you are very much familiar with your Wheaton's bridge. Many of the experiments also you have conducted using your Wheaton's bridge. Let me call this as R1 or R2, R3. Now this one RST, resistance with strain, right? Let us say that I have got a galvanometer, and between this I have got the supply. I am not going into the details of this. So now whatever you have which changes the resistance, that you will put as one of the arms in your Wheaton's bridge, right? So which otherwise the whole bridge would have been balanced here with a particular initial resistance. Now your RST is R plus delta R after you put the pressure on this. Same thing happens in your strain gauges also, as you can see. So you have got some cantilever type of thing here. You deploy the strain gauges here, 4, 1, 2, 3, 4, something like that, right? So whenever the pressure is put here, the resistance changes, and change in the resistance can be found in the form of change in the current here. So ultimately I want to have the action of a transducer. So I would like to have the output to be in the electrical form. The physical parameters getting changed will give me the output in the electrical form. Okay, so this is what I mean by a flex sensor here. Okay, so the flex sensor is basically whenever the pressure is put on the two ends, whenever the strip is bent, then its resistance is going to change. That is what we mean by flex sensor. Then you have got the resistance sensor, organic vapors. A gas sensor senses the change in the gas concentration when that exhibits the measurable change in the characteristic circuit of the parameter. Resistance of a sensor of an organic solvent vapor shows the measurable drop with the vapor's concentration in the vicinity. This is how your gas sensors work, right? So ultimately, whenever the gas sensors work, being an electrical engineer, I am not interested how they work, but what electrical changes I am going to get whenever there is a leakage in the gas. So based on that, I wish to make my further values, right, calculated, or the enriched or the gathered, so that I can put these values in my subsequent layers for the further analysis or the interpretation of the data. So this is how the resistance change or the change in the resistance of the sensor happens because of some change in the physical values or the analog values, change in the value of the resistance. So whenever there is a change in the value of the resistance, then you can make use of your electrical mechanisms, whatever you have, the different bridges, right, or any kind of thing. You can use a potential divider, right? So now you can put it here, this you can put it here. So whenever there is a change in the resistance here, whenever there is a change in the resistance, the voltage across this keeps changing, right? So I will get the output in the form of the voltage. In a Weiston's bridge, I will get the output in the form of the current. So these parameters are as a result of change in the resistance because of the analog quantities which are being measured, which by means of the analog sensors, right? So for today's presentation, we will have only this much, and in our next presentation we can have some more information on the sensors and the subsequent aspects. If you have any doubt, please get back to me. I will stop here now. Thank you.